In this video, we're going to talk about the concepts of reliability and validity in research, as well as the concept of some research ethics. When we think of reliability, we are referring to consistency of data. When we think of validity, we're referring to accuracy. What do I mean by consistency? Reliability asks the question, if I give this assessment over and over and over, would I get the same or very similar outcomes? And the goal is to have high reliability, and that means to have some level of confidence that the results are consistent. And we do things different ways. In the case of some of the observational data, we understand that there are individual differences in what we see, and our experiences might differ. So we might use a form of reliability called inter-rater reliability. And inter-rater reliability basically asks, do I have consistency across observers? So if I am watching a karaoke performance and I'm a judge, and Eileen is watching a karaoke performance and she's a judge, would our scores match? Or would they be similar in terms of the rating of performance? The degree by which they match is what we call inter-rater reliability. And when it comes to certain things, we have really, really good precision. So if we're trained observers, the hope is that Eileen and I would match in our observations. So let's take an example like gymnastics. Gymnastics is an Olympic sport where it's not uncommon for judges' ratings to be within 1/10 of a point of one another. And that's how precise it is. That means we know what we're looking for, and we're able to get some level of consistency. It isn't the case with all sports, though. So if we were to look at the fighting sports like boxing or MMA, mixed martial arts, it's a lot harder to score those bouts because I might be looking for one thing and you might be looking for another. Did we both see, let's say in boxing, the punch land? So my score could be very different based on what I saw or didn't see. And there's a couple ways people evaluate around. Some people evaluate how many punches landed, as I discussed. Other people evaluate how aggressive or active one fighter is over the other, and they'll give the edge to the more aggressive fighter because the assumption is that they might have landed more punches, right? So there are these two models. And the problem with that is that you have what's called a split decision. So in boxing, you might have one judge say one person won and another judge say the other person won. Now you have three judges for that reason, because you can break a tie, right? So the third judge is going to say, okay, this person I thought won, and then whoever has two judges say they won, they're going to win, right? Interesting to note, though, even so, you can have what's called a split decision draw, where the third judge says, no, I thought it was even. So that's a good example of poor inter-rater reliability. In research, if you have poor inter-rater reliability, then you cannot draw meaningful conclusions. So we test the consistency of the observations, of the ratings across people. And there's a statistic called a Cohen's kappa that you can run to determine whether there was consistency. So that's one form of reliability. There's another form of reliability, especially when we talk about developmental paradigms or longitudinal paradigms, which we refer to as test-retest reliability. So if I give you a test at 2 points in time, I would expect your performance to be roughly the same at point A and point B, right? So if I give you an IQ test, Lara, today, and I give you an IQ test in 5 years, I would expect your IQ to be roughly the same, roughly stable, because IQ is about your adaptive functioning and your potential. It isn't about just acquisition of knowledge, right? That's an achievement test. So if I give an IQ test, I would expect it to be pretty stable. So test-retest reliability, I'm giving the same person the same test at 2 or more points in time. Now, obviously, we have the problem that we talked about in the earlier video of practice effects. When you give the same test to the same people at 2 or more points in times, the questions are going to be identical. People are going to start to remember the questions, especially if the assessments are closely related in time. So the shorter the distance between the administration, the more people are going to remember. So it's possible that you get what's called artificial reliability. And artificial reliability is basically that the person remembered the question, remembered their answer, and they just said the same answer. Right? Not that that's what they believe to be true, but they remembered the question, remembered the answer. Another problem with test-retest reliability in general is that it is possible that people grow or some kind of life event between administration A and administration B alters how the person perceives things. So if I, for example, if I were giving you an achievement test and I wanted to measure your mathematical ability at the beginning of a school year, and I measured your mathematical ability at the end of a school year with the same test, what would I expect? I would expect you to perform better at the end of the year because I'm hoping that you learn something about math in that year. So there's something called maturation, and test-retest reliability cannot get rid of maturation effects. Now, remember in the test, the artificiality, we can deal with that. There is another way of approaching giving tests repeatedly. So if I'm going to give you a test at multiple points in time, I could use what's called alternate forms reliability. And here is the cool thing. You have 2 tests that are measuring the same concept, but the questions are different. So you can't remember the questions. So an example of an achievement test that uses this model is something called the wide range achievement test. And they have a green version and a blue version because these tests are going to be given to the same people through time to check mathematical growth. So if it's measuring the same concepts, then I can see if you grew or matured. But you're not going to get an answer right just because you remembered the question. You have to know the process. So alternate forms reliability is you're giving different versions of the same test to the same people at 2 or more points in time. Different versions of the same test to the same people at 2 or more points in time. If you've ever been in a class that the professor had a version A, B, and C of an exam, version A, B, and C, these are alternate forms. These tests can have the questions the same but jumbled up in different orders, Or it could be that there are different questions in version A, B, and C, but it's still measuring the same topic area. People can't cheat off of one another if the person sitting next to you has version B and you have version A, and then the other person has version C. Harder to cheat. So alternate forms reliability is a really cool strategy. Different versions of the same test, the same people at 2 or more points in time. But the assumption of alternate forms reliability and test-retest reliability is that you are going to give a test to people at 2 or more points in time. What if you don't have the ability to test at multiple points in time? What if you don't have the time to do so? There is a way to test the reliability of an instrument at one point in time. And we refer to this as split half reliability. So what would we do? Let's say we had a 100 item test. We would divide the test into 2 tests of 50 items and correlate the 2. Now, typically, the best way to split tests are odds versus evens, not 1 through 50 and then 51 through 100, because we also know that people can get fatigued in very long exams, right? So you might have more energy in the beginning and get tired as you go through. So if you split the halves, odds versus evens, your motivation on item 1 is roughly the same as your motivation on item 2. Does that make sense? And your motivation on item 49 is roughly the same as your motivation on item 50, because that's smack dead in the middle. And your motivation at 99 and 100 is roughly the same because it's at the end. So we don't want to introduce some other problem of first half versus second half. Best way to do it is odds versus evens. And for our reliability measure, we want a correlation of at least 0.7. The weakest correlation that we consider acceptable is 0.7. Most instruments have a much higher reliability score of 0.8 and 0.9. Now, split half reliability, we're taking one correlation, part A versus part B. There is a more sophisticated statistic which we then look at every individual item relative to every other one. And that's what we call the Cronbach's alpha. The Cronbach's alpha, we're going to correlate item 1 with item 2, correlate item 1 with item 3, item 1 with item 4, all the way to 100. And then we're going to take item 2 and then correlate against every other item, and then item 3 against every other. And then the alpha of the Cronbach's alpha is the average correlation of the 2. So of all of, pardon me, I'll say that better. The alpha of the Cronbach's alpha is the average correlation of all correlations. Once again, we're looking for a value of 0.7 or higher to be an acceptable Cronbach's alpha. So this isn't every aspect of reliability. There's a lot more to go into this, but I'm giving you a sense of what reliability is. Very broadly, reliability looks at consistency across scores. Now, validity is about accuracy. And when we talk about accuracy, we're talking about, does what we're testing actually measure what it says it's measuring? Does that make sense? So we're looking not just for consistency, but accuracy. And reliability and validity are not the same thing, because it is possible for you to have a reliable measure that is not valid. How does that work? Let's say you were, you owned a produce store, and your scale was a little bit off. The spring on your scale was off. It is possible that everybody might be either overcharged or undercharged by a certain percentage of a pound. But because it's what it's off is consistent, we would say it's reliable. So let's say it was calibrated to minus 1/10 of a pound. Everybody's going to be charged for produce that's off by 1/10 of a pound. So is the scale consistent? Sure. It's consistently off by 1/10 of a pound. Now, is the scale accurate? No. So in that case of a scale, it would be reliable but not valid. And if I were the person who owned the store, I would be losing money on every purchase because it's not calibrated to zero. It's off by that 1/10 of a pound. Now, I would be upset as a business owner. Now, you would be upset if the reverse were true. Imagine it was calibrated to add 1/10 of a pound over what you're actually getting. So now you're overpaying. Again, that scale would be considered reliable because it's overcharging 1/10 of a pound, but it's not valid. It's not what it should be putting out there. Does that make sense? So accuracy is about precision, or validity is about precision. Does this measure what it's supposed to be doing? Is it a true representation of what we're saying it is? And there are three types of validity. There's internal, external, and construct validity. When we talk about internal validity, if we were doing an experiment, we would be asking a question: does the independent variable truly cause changes to the dependent variable? Now, we said when we talked about an experiment in the previous video that an experiment, you have to get rid of confounds, right? In order for you to say that the independent variable is a cause or a cause to the changes in your dependent variable, we got to get rid of confounds. So internal validity is a form of a way, or a form or way of assessing the degree to which we can say the independent variable caused changes. If we eliminate confounds, then we're going to say we have strong internal validity. External validity. External validity is our ability to generalize from our study to the real world, or generalize from our experiment outside of our experiment. And when we talked about in the observational research lecture, a lab-based observation versus a field-based observation, one of the things we said was that the lab-based observation has greater internal validity because you can control for outside factors. The problem is that the lab could be very artificial. And because the lab is artificial and it was such a sterile environment, perhaps in the real world it doesn't look that way. So when it comes to lab research, a lab-based observation, it might have weaker external validity. And I said to you, in the case of experiments similar to our observational, we do have something called field experiments, right? And field experiments have greater external validity because they're happening in the real world. So it's easier to generalize to the real world if it has that mundane realism. It's happening in the real world. So we talked about internal validity. We talked about external validity. And when it comes to psychological instruments, we have to worry about construct validity as well. And construct validity refers to, does this instrument, is this an accurate measure of what we claim it is? So if I were talking about intelligence, as I discussed earlier, intelligence, I would say, is this instrument actually measuring intelligence? So the degree to which I can say this instrument that is labeled as an IQ test is accurately measuring intelligence, that would be construct validity. Does that make sense? If I were to create an instrument to measure happiness, construct validity would be asking, does this instrument truly measure happiness? If I were creating an instrument to measure substance abuse, construct validity would be, does this instrument actually measure substance abuse? And so forth. So it isn't just about, did the experiment pan out? It isn't just, can we generalize from our experiment to the real world? We also have to ask ourselves, were the instruments we use actually legitimate? And construct validity test these theoretical ideas within psychology. Now, if you were to look at an instrument and you were to try and determine whether it was a valid instrument, so now we're talking, doing a deeper dive on construct validity, you would look at it through many different prisms. The first thing is face validity. If I look at this instrument, does it look like it's measuring what I claim it's measuring? So if I created an instrument about substance abuse, I might give that instrument to 3 unassuming individuals and say, hey, what do you think this instrument measures? And if all 3 of those people says, yeah, it looks like it's measuring substance abuse, then I know the visual perception is that this is a substance abuse measure, and therefore it has face validity. What is the problem of only determining construct validity from face validity? Can anyone think of a problem of using only the way it looks? Let me see if I could call on someone to think about it. Abigail, what is the problem if I only use face validity as my marker of construct validity?
I mean, maybe it's like everyone has their own like perspective on like what an object looks like. So unless they know,
Not an instrument, so a psychological assessment.
I mean, like personally, like everyone, I just don't understand. Like you can't test an like how it an object. I'm sorry, the instrument that is being like measured that is measuring it. The problem is like everyone. If you don't really know what's measuring, you have to have like an opinion. So you wouldn't really know unless you like understand.
I gave you a questionnaire, and the questionnaire asks as follows: in the past 2 weeks, have you experienced decreased motivation? Another question: in the past 2 weeks, have you had changes in appetite? In the past 2 weeks, have you been quick to tears? And so forth. If I asked you, what do you think that instrument is measuring, what would you say? Still, Abigail, if you had to guess what that instrument was measuring.
I would say maybe like depression.
Good. Now, if I show 3 people that instrument and all 3 people say this instrument's measuring depression, then I have some level of face validity. By the way, those are 3 items on some depression inventories. So that's interesting. So you accurately said this instrument looks like it's measuring depression. That's face validity. Now, my question is, what's the problem with only relying on face validity? And I'm going to move off of you. Can anyone suggest what problem might occur?
Might not give you the correct measure, I guess.
Can you explain a little bit what you mean?
I think you might need like a different variables, I guess, like different way of measuring of the. So in this case, you're talking depression, right? Like measuring depression, like someone's states of the emotional states of, right? So I think it's important to have a different validity, I guess, to measure instead of relying on just on one variable.
But why?
So you can have a better result.
Very vague. I'm going to give the answer. The answer is simple. Anyone ever hear the phrase looks can be deceiving?
Yes.
Right. So that phrase is relevant to instruments. Some instruments are designed to be subtle. So you might think it's not measuring anything, and it's a really good measure of whatever you're looking at. So we talked about substance abuse. There's something called the SASE, which is a subtle assessment of substance abuse. We have something called the Marlowe-Crown, which is a very subtle measure of social desirability. And because of that, some instruments are designed to be undetectable what they're looking for. So if I just rely on what people perceive the instrument to be measuring, that the instrument may be a good measure and you might miss the boat. So we do have other ways of assessing construct validity. So there's something called criterion-oriented validity, which is how much scores on an instrument is related to an outcome or criterion. So one example is predictive validity. How accurate can I use this instrument to predict an outcome? So if I were to use the SAT as a predictor of performance in college, how good is the SAT at predicting? That would be a measure of criterion-oriented validity. Another example is concurrent validity. All instruments should be sensitive across the full bell curve. If I were to use the SAT as my example now, I would ask the question, can the SAT separate out high performers, moderate performers, and low performers on the test? A third example of criterion-oriented validity is convergent validity. Now, convergent validity is you have two measures of the same construct. We believe they should get the same or very similar results. Is there another thing that people put on their college applications other than SAT? Is there another test that people take? Anyone know what it is?
Regions.
So the Regents, sure, and that's a New York thing. So the Regents are helpful. If I compare your Regent scores relative to your SAT, high achievers on the Regents should be high achievers on SAT. But there's actually another standardized test called the ACT. The ACT and the SAT are strongly related. So if you get a high score on one, I expect you to get a high score on the other because they're both measures of achievement. Does that make sense? So that's convergent validity. Two measures of the same theoretical construct should result in the same or very similar outcomes. The scores should converge, should come together, right? Be very close. Whereas we also can detect the opposite, which is called divergent validity. Two measures of different constructs should get very different outcomes. If I give you a reading test and a personality test, should your scores be related, your reading abilities and your personality? Not necessarily, right? So I wouldn't expect the scores to be strongly correlated. So divergent validity, the scores should diverge. They should be different from one another. Two measures of different theoretical constructs should get different outcomes. All right? So the last thing I want to talk to you about is research ethics. And I think this is important because whenever we do research, we have to be mindful of whether the research is appropriate. And there are several protections we have when doing research, especially with children and especially with people with psychological illnesses and so forth. We have to protect the participant from any form of physical or psychological harm. So we ask ourselves, cost benefit. What is the cost? What are the risks associated with participating in this study? And what is the likely benefit to the individual or to society from participating in this study? And research ethics boards only allow studies to proceed if the benefit outweighs the cost, if the benefit outweighs the risk. And if you're not sure, then you probably shouldn't proceed with that research. And every school, university has what's called an IRB, Institutional Review Board, which is a neutral body that determines the safety of your study. We do not just rely on a researcher themselves, because I might think, yeah, this study's worth it, but I need to have an outside body or board review the study and come to some determination, because I have my own biases, right? So we protect people from harm. That's what we refer to as beneficence, right? We also require people to know what they're getting themselves into. And this is consent. Now, I'm going to break down the two words. It's called informed consent. Consent means that you agree to participate. But we're not just asking whether you agree. We want you to know. Remember all those risks that we talked about are potential in the study? Before you agree to participate, we want you to know the potential risks. We also want you to know the potential benefits. And only after you know risks, benefits, alternatives to participation, and so forth, can we ask you to agree to participate. So all studies have what's called a consent form, where we list, and it's usually 10 or 12 points, what the purpose of the study is, what the risks associated with participating are, what the benefits are, alternatives to participating if it's like a drug study, the right to withdraw participation at any point in time. Now, consent is an ongoing process. So in our informed consent form, we let you know you have the right to change your mind at any point. We also provide you information to the IRB. So if you have questions about the study or the ethics around the study, we give you contact information to who you can reach out to. And if it's a mental health study, many times we give you information on local mental health treatment centers and so forth. So these are all part of the consent form. We need you to know what you're getting yourself into, and with proper awareness, make a decision one way or another. Now, informed consent is written in very plain language, usually written at the grade level of 3 to 6, so that you're not being tricked in any way. It should be written very plainly and in the language of the participant so that they understand the consent form. If you're working with children, the consent process is a little more tricky because children can't give full consent. So you rely on both the parents or guardians and the children to give consent. And if either one changes their mind or doesn't provide consent, they're not allowed to participate. So there's extra protections when you're dealing with minors. Now, there are other issues related to research ethics. Everybody has a right to privacy. If you participate in a study that is protected information, it should be locked in a secure filing cabinet. If you're worried about the information being found, you could separate the demographics questionnaire from the other information so that you can't put the data with a specific person. So you have a right to privacy. Now, there is a difference between privacy and confidentiality. Privacy typically refers to the right to not share something. Confidentiality is once something is shared, making sure it doesn't get out. So I want to split those hairs a little bit. So we also have to be mindful that some studies, if you tell people what you're doing, it's going to alter their performance. So there is a process that allows for deception, where the experiment temporarily misleads either the purpose of their study, or they might have an actor alongside their study. But if you use deception, number one, it has to be the only way you could have gotten these results. So an IRB is not going to approve deception unless that's the only way to get the data. Number two, you have to engage in a debriefing exercise. Debriefing is the process where you tell your participants what the real nature of the study was. You explain to them why you had to use deception. You answer whatever questions they might have, and so forth. You also give them the right after debriefing to choose whether they want you to use your data, because now after the fact there is still a question: would they have wanted to participate if they knew the true nature of the study? So we give that permission back to the participant and say, hey, here was what we were really studying. Do you have any questions? Do you have any problem with me using your data now that you know ... So that's debriefing. When do you debrief? Typically, you're going to debrief immediately after the participant finishes the study, so that you don't leave them in limbo thinking the study was something that it wasn't. If you are worried that through debriefing right after the study, after their participation in the study, that is, that's going to alter future participants, you can do debriefing once all of data collection is done. But the IRB is going to have to approve that. So debriefing, you're telling the true nature of the study. When you do debriefing depends on whether you're worried about, the deception in the study getting out to future participants. And the other thing, we strongly dissuade people from using deception when doing research with children. because children are far more impressionable and the deception could have more profound effect. So that is our lecture on reliability, validity, and research ethics. So I'm going to stop the recording there, and I'm going to see if there are any questions.